Bitcoin is close to becoming worthless.
Let's go. Now, what's the Bitcoin?
Bitcoin's like rat poison.
Yeah. Oh.
The greatest scam in history.
Let's get it.
Bitcoin will go to fucking zero.
Yeah.
Alright, you ungovernable misfits. I'm your host, Max. Everybody knows that Bitcoin is useless, worthless, and doomed to fail. But what if everyone's wrong? What if it's the system that is doomed to fail? Join me as I speak to some of the brightest people in the space and slither to the deepest, darkest depths of the Bitcoin rabbit hole. Welcome back to another episode of Pleb Miner Month, the extended version, the version that cannot fit within 1 month. In this episode, John speaks to CoinHeated and to Anton from AIPro Energy. I lurked in the background for most of it, jumped in with one pointless question and then fucked off to do another interview. So not much of me in this one, but it was a brilliant interview and I love what these guys are doing. Make sure to check them out with the links below, and as they said in this recording, just reach out to them if you have any questions. I love how open these guys are, I love how innovative it is, and I also really like the fact that they've got a phone. They can actually phone and speak to someone, which is fucking cool. So yeah, that's all from me. I just wanted to say thank you to everyone who's been involved in Pleb Miner Month. Really is incredible to see just how much content we have, and well, we just couldn't fit it in a month, so it's a good problem to have. We have, I think, 3 or 4 more episodes in total to come, so look out for those. And I just want to say thank you to my sponsors. Firstly, thank you to my anonymous sponsor who has made it possible for me to continue this show. I really do appreciate it. It is pretty mind-blowing that someone I've never met or spoken to listens to the show and gets enough value from it to give back. So thank you so much, and to everyone who's been involved in the value for value using Fountain or Breeze, I really appreciate it. Every sat helps and I love all the personal messages. I also want to say thank you to Foundation Devices. Foundation Devices are making my favourite hardware. They are also going to be doing 2 giveaways. That was supposed to be out weeks ago, but just too much content. So look out for that, for the chance to win a Foundation Devices passport. They are fully open source, they are fucking gorgeous, and they're so simple to use. Check them out at foundationdevices.com, and if you decide you'd like to buy one, you can use the code BITBYBIT. You will get $10 off. Next up is Fast Bitcoins. Fast Bitcoins are a team based in the Isle of Man. They are a KYC service, an on-ramp and off-ramp for anyone looking to interact with Bitcoin and dirty slave notes. Although I push very hard on this show for nobody to use these KYC services, they do continue to support this show, and I'm very grateful for that. What I would say to anyone is, if you are going to use a KYC service, I advise against it, and it's amazing they actually support this show, but if you are going to use one, you really need to make sure you use a good one. These guys, in my opinion, are the absolute best. They really care about their users, they do everything they can to protect you, they push you to get those sats off exchange, they do not want to hold them, and they don't do any extra bullshit compliance like some of the other fucks out there. I have a huge amount of respect for this team. They are always at the forefront. They were the first exchange in the world to implement Lightning. Danny Brewster and the rest of the team are fucking awesome. So if you are going to use a KYC on or off ramp, go to fastbitcoins.com and enjoy the show.
Good morning, Anton. Good morning, CoinHeated. How are you guys?
Doing good. Good morning.
Morning, John. Pretty good, thank you. Thank you for the invitation.
Thanks for all of your participation in Pleb Miner Month. I think it's going pretty well so far. We are recording on the third day of Pleb Miner Month, and already we've given away a t-shirt and given away a hoodie. Today's giveaway is a seed signer build.
Nice.
So it's pretty exciting to provide the plebs with that kind of gear, but also exciting to bring them innovators and creators like you guys are. So why don't we start with CoinHeated? Can you kind of explain who you are just real quick, even though most
Sure.
everybody knows, and then
Well, I
Anton
wouldn't say most everybody, but
yeah,
yeah,
most everybody listening to this podcast.
I'm just a pleb at heart. I heard about Bitcoin back in like 2010. I really didn't understand it. I mean, hardly anybody understood it back then. And it's just
Yep.
like, what is this weird internet money? What am I going to use it for? There's no exchanges. It's worth like almost nothing. And it's like, I didn't get it. And then, for the next decade, when it started actually gaining in value, it's like, oh, I missed the best time. 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 And then finally in 2020, I'm like, I'm tired of saying that. I'm just going to get into this. I don't care. But I mean, I didn't really, I wasn't on Twitter. I didn't know any groups. And so I just kind of did my own thing. And then I learned about immersion pretty quickly. And then I just got completely obsessed with that. And I started heating my swimming pool, and I posted a YouTube video, and then that got shared by somebody. And actually, I think it was Neil Ronan Miner on Twitter, and he shared it out. And then all of a sudden, everything exploded, and now here I am.
I remember the evolution of that whole thing. First seeing it being posted by Ronan Miner, and then I think you had a YouTube channel up as well. And I immediately went to that.
Yeah, I shared it on my just personal account because I just meant to share it with like a friend of mine or something, and then all of a sudden people are subscribing to my own personal one, which just only has like 4 videos at all, it's nothing. And then I'm like, okay, well, whoops, this is too much. And so then I just made a different channel for that. I've not really put much video on there. I'm not trying to make it be a content creator or anything wild like that, but just needed to keep it separate from where might have videos of my kids playing around or whatever.
Yeah, that was kind of a smart move that I saw. Like, wait a minute, I'm starting to get popular on Twitter here for what I'm doing,
Yeah,
and people are coming to look for that kind of content, and I
right.
don't want my kid's birthday
Th-
party on
yeah,
there.
I was like, what the hell is this? Why am I subscribed to this?
So you start getting into immersion and building all of your machines, and from what I remember, that they were all kind of in aquarium tanks on a rack and
Yeah, and so
in a shed type environment.
yeah, and so what I did is, I mean, I was on a shoestring budget. It's just, I'm not rich by any means. I'm just doing what I can, and so I found some people doing it in aquariums, and I figured out that a 40-gallon breeder aquarium is only $50 at Petco or whatever, and I did that and set it up on the cheap for the most part, and had a lot of learning, which is good. I definitely enjoy that, but and at that point, then that's when that video started to go up on the pool being heated, and then that's how I found the guys over at AIPro Energy.
Okay, so
I should say that's how they found me.
Anton,
Because
you sought CoinHeated out once you saw that material. What did you think when you first saw it? And why don't we back up a little bit for a second, Anton? Why don't you kind of you go over who you are and who AIPro Energy is and what you guys do?
Yeah, absolutely. Anton Galvas, managing partner at AIPro Energy. We are a mining infrastructure company. So we manufacture and service mobile mining infrastructure and technology. Sounds cool, fancy, but in reality, everything started from home. Mine at home. We grown up outside of home, trying to place our miner somewhere and learn about shipping containers. Bought one modified 300K 350 kW, moved out on interesting energy sources like natural gas. Just was lucky to find one of the location back then, and then decided to build a little bit more later, and end up to be in manufacturing, and first with containers, and then one of those days, just browsing, YouTube, noticed some interesting video, and was CoinHeated, showing some of this cool thing that he's doing with those aquarium, and actually, almost like next day, we already jumped in the plane with my business partner and said, like, let's fly from Texas to Minneapolis and meet the guy. So we spent like a couple of days there. It's amazing. I mean, it's truly innovator, and generally everything I see, Twitter plays significant role in a progress with just meeting people. In miners, generally, pleb miners, they really in a way risky, right? Taking a lot of decisions fast, and magic happen.
Yeah, we don't have any investors or a board or anybody to please but ourselves. And so you guys saw the aquariums and the setup that he had and the pool, and you fly up to the great white north to see him and visit with him. And what about his setups that were different? And CoinHeated, you can kind of go into this too.
Sure.
About what you were doing, and Anton, what did you see that he was doing that was interesting, different from everybody else?
Yeah, definitely. Simplicity is a big deal. We already observed with mobile mining containers. You want to be relatively plug and play, simple, and then efficient. And he just based on his garage lab was amazing. He tried all kind of variation of placing heat exchangers in different ways, and one of them most efficient was when he just use minimum fluid, place miners as close as possible, put radiator inside essentially, and then using miners fans to move fluid around with everything was bubbling, and it was obvious it was a pretty good flow happening. And then we asked like, hey, is it reliable, CoinHeated? And he said, yeah, I've been running it for like 8 months, I believe.
I think it's like 4 months by then. Yeah.
Oh, 4, okay, yeah. And absolutely, we was just fall in love in technology. He's an amazing guy, and we said like, how can we be part of it? And that's how we started.
I should say I've been running fans in oil for like a year at that point already, and there's the train of thought like, oh, you can't run fans in oil, that's terrible, and it's going to use up 10,000 watts of power, and
Yep.
it's like, no way. I mean, come on. It's an electric motor, it's in oil, so it's going to be lubricated, and I've actually not had a fan failure, maybe only one at this point.
And you can
Except for
have
a
that in an
particular
air-cooled
brand.
environment as well. It's
Yeah,
it's not like
exactly.
it's
And
exclusive
so,
to fluid.
right. And the amount of flow going through was so substantial. And then in addition, you didn't need to really make any other mods. I was doing fans in the aquariums to begin with, just to get some flow through it. And then, I was kind of just thinking, I got completely obsessed with this thought, and then this is when Anton and Artem come down, and they're like, "Okay, we want to make a tank for, for a container." And so I'm like, "All right." And then I just got completely obsessed with the most efficient way to do this. And so, and in my mind, I just take this, I just have this open cloud of space in my mind, and then I have this miner just floating around up there, and then I have oil going through it and somehow magically circulating back into it. I'm like, how do I make this into a real thing? How do I cool that oil in the loop? And I ended up taking a water to air heat exchanger and redesigning that in a way that it was inside the tank, and then I used I just used the fans on the miners to circulate the oil because it was already doing far better than pumps would, and it's dramatically easier, and it's less modification because you don't need to, flip the cards around. So far as I know, in every other immersion setup where the oil comes from the bottom, slowly rises up through the top, and then you have to flip the ASIC cards around because the flow is in a very specific way, and that has to remain. But then you have to flip the PSU control board around because the cables come out, they have to come out the top unless you can somehow have all your cables come out the bottom, which I don't know how you do that. But and I'm like, why am I doing all this? And then the last thing was, pretty much everything else was designed with a more generic size and capacity. I'm like, well, you know what? I'm just going to make this only for S19s, and that's it. Nothing else fits. I don't care. It's not a catch-all solution. So I started off with just S19s. I made it only for S19s, and I made it exactly perfectly efficient just for those machines to work in exactly that way.
I just want to give everybody a little bit of context that's not exactly familiar with immersion systems. A lot of the initial immersion systems kind of stood on a rack or a standoff, and you could mix match all kinds of different miners in
Yep.
a giant tank and just kind of expect the laws of thermodynamics to work there, and heat is going to rise up through the cards, and
Yep.
you're going to kind of have an overflow on one
Yep.
side of the tank split off by a divider, and that's going to get pumped out to be cooled. A lot of times that single loop dielectric coolant is going to go out to be cooled and then get pumped back in. But what you're
Exactly.
doing is a two loop design, and you're not depending on the laws of thermodynamics. You're using two of the fans that are on the S17 or S19 to
Yep.
draw the fluid from the top down through the machine,
which keeps the card the flow the same way that it was designed for. I mean, it was designed with airflow, but the oil flow or the heat flow remains the same, I should say.
and I'm sure that's kind of been a hurdle for you to get over. And I've seen it with myself interacting with people in the immersion group, and then you've kind of been in there, and the two of us and other people in the immersion Telegram group are like, they just don't get it. How have you been able to get over those hurdles of people not initially understanding what you're doing?
Because I don't worry about it, and
Well, yeah, that sounds like you.
yeah, like because I just made this thing and like, look, this works, and if you don't believe me, just try it. It's really that simple. I've been running it for, like I said, I've been running fans and oil for about a year, but by the time I kind of finalized the HotBox Liu design, and I did a lot of research on computers and stuff that were running oil, and there was reports of like, yeah, we've been running a fan and oil for 3 years or something silly, and there's the whole, like I said, there's the, oh, fans use so much power, it's crazy. I'm like, well, I looked at it, and at an absolute max draw of 12 volts, at whatever amps, I figured out it was like maybe 150 watts. You're going to have to move the oil, whether it's an actual large pump or if
Right.
it's individual fan. Like, I mean, you're moving the oil. It takes X amount of energy to move the oil. So, I didn't really worry about that so much. If you're talking about absolute maximum efficiency, you're probably looking at something else anyway, or like absolute minimal cost savings. But what I did with the tank is I completely removed the oil fittings, and that was something that always annoyed me, is trying to find CPVC
Mhm.
or oil rated stuff, oil rated hoses. You'd have to get like hydraulic lines, or there's stuff out there, but it's difficult to find.
Yeah.
It's expensive, and quite frankly, I was like, why are we even doing this? Just because everyone else has been doing this, and that's kind of how my brain works. Is like, I just basically throw everything out the door and be like, okay, let's start with absolutely nothing, and that's what I was saying. Kind of like in my head, I just started with this ASIC, and just floating out there with a loop of oil magically floating back through there, and then I started putting things in place in my mind that like would actually work in reality.
Mhm.
And then that's when I came up with that concept. And like, so the only thing coming in and out of the tank is a water loop. It's technically a two loop system because there's an oil loop, but it's all completely inside the tank. And then
Mhm.
there's a water loop that comes in to an external source and goes off to cooling somewhere else.
And just to say, like the capex on going immersion is already pretty high, and a big chunk of that is the fluid itself. And so a lot
True.
of these systems, like, when Engineered Fluids kind of came out with their slick system and all the other
Yep.
systems after that, you're using a lot of that fluid, which is very advantageous for Engineered Fluids because they get to sell
Sure.
a lot of that material to be pumped around and cooled. But a water glycol mix is pretty cheap. So I want to bring things
Absolutely.
back to Anton. Anton, you guys go up to the Great North and you see that he's doing things differently. And so how did you kind of bridge that gap? You're like, all right, well, you're some guy in a garage who's got, what was at the time? He had like 800 amps somehow when heated.
400 amps just for ASICs. I mean, because I had 600 in the
Yeah.
house in total. I had 400
Okay.
just for the ASICs outside, and then I had 200 for the rest of the house.
I
Plus,
remember it being quite a
Yep.
bit in your old house. So you
I mean,
go
I
in.
blew the transformer for each. Like Excel had to come out into my backyard with the trucks and everything 3 or 4 times.
There's no greater war story than that. So Anton, you go up to Minnesota and you see what he's doing. How did you kind of say, okay, let's bridge the gap here. Let's go from a guy in your shed or in your garage to manufacturing something?
Yeah, absolutely. So we obviously was excited with the system, and we thought, okay, we'll try to build essentially some kind of ecosystem around this. And we just returned back to what we do good, and we thought like, well, we built containers already at scale, so let us try to build an immersion cooling container. And for that, maybe we need to start from building those, replicating those tanks, and going through engineering design, like this. We got engineers and all this, and just checking all this thermal modeling, first principles. And what is interesting, at the beginning, when our engineer ran model, he's like, well, it doesn't make sense. It should be definitely improved. Placement of this radiators and area of flow, it doesn't look right. And so it was interesting communication between John and engineer. And John actually won. Engineer at some point said like, listen, I think actually what John designed, it's actually more efficient than I thought. And let's keep it as is. And he've done it after extensive modeling. So what John came up with was obviously very, very efficient. And then we got we already believed in technology and to start building racks. We built slidable racks, like three tanks per rack. At that time, we didn't discuss much about giant overclocks. We were thinking like, okay, we go like 4,000 watts. Maybe that would be already good without noise and everything.
Yeah, not something extreme. Just a 500 more watts over.
Yeah, yeah, and so that's why kind of overclock. It's a second milestone for us. But yes, we built racks, and then from racks we kind of backed off and said like, well, let's simplify it, and maybe instead of doing slidable racks and going to containerized solution, because it will take a little bit time. Let's go faster and actually serve B2C market, serve pleb miners, and try to bring something that handy, not bring extra cost, will be affordable. And we end up just building tanks itself, and working more on overclock and working more on optimizing electrical and some other stuff around it. And this is where kind of second milestone happened when John came over here to us, and we've been on real field project when connecting all this tanks to chiller, and testing how far we can go with overclock.
Yeah, that was a whole different thing. So we're having like 42 degree Fahrenheit water. So I mean, it's cold water coming in. Very different than like what I was doing with a swimming pool, and there's some different challenges with that. But that's when we really got to see how much it could really overclock in that tank, and it was actually pretty wild.
Can I interrupt you for a second? Was this
Yeah, go ahead.
testing in Minnesota, or was this testing down in Texas?
This was testing in Texas, but it was hooked up to a chiller loop. So
okay, gotcha.
you got the really cold water coming in because of a chilling system.
Yeah, and what is interesting, like in early experimentation, we didn't even change PSU. I don't know if you want to go to details, but yeah,
we want to go into details. Yeah,
yeah.
The stock PSU handles 5,000 watts, and the tank itself very easily handled all 6 at 5,000 watts. but we found that 125 amp PDU does not handle 30,000 watts, and so we're like right on that border of 125 amps, and so we had to find a better PDU, and then go to three phase.
And that did you guys get Alpha Miner power supplies?
Yeah, we received Alpha Miner. We actually bought a couple of other suppliers, PSUs that we installed. And
Could you name them? Nobody's a sponsor, just to get more of the information out there for everybody.
yeah, so it's my Bitcoin, one of them. I'll double check exact name. And One Stop Miners. They One Stop Mining. They provided us with fanless PSUs.
And correct me if I'm wrong, but they were stock PSUs that had the hardware mod done to them. So they're not ground up built from scratch like the Alpha Miner ones. They're the modified stock PSUs that have
it could like companies like Kaboom Racks will take the PSUs and make the mods and resell them. Kaboom Racks is also helping out with Pleb Miner Month, just to give them a little plug.
Yeah, and we communicate with Kaboom Racks, and definitely looking forward to test PSUs. We just by that time we already grabbed 3 vendors, and we just didn't get yet there. But we'll absolutely planning to test it, and we're looking forward to it. So, but meanwhile, just let you know that we bought first 6,000 watts PSUs and run them up to 6,000 watts. And then we actually ordered and learned about 8,000, and then went to 8,000.
Wow.
8,000 was instantaneous, and John can talk about this, but we went to the biggest one actually and most steady was 6,500, and I would let John probably explain why we actually stopped at 6,500.
Go ahead, CoinHeated. Just for the audience, so there's no confusion, CoinHeated's name is also John.
Right. Well, we kind of stopped at that, and what we found was at 6,500 watts, having the flow that we had with the chilled water we had with the specific, the tank that I designed that's basically the max thermal, amount of BTUs that we could suck out of that small tank, and we're going to probably look into doing a max overclock tank, which actually has more cooling on top of that. But at 6,500 watts on all 6 miners, so what is that? 40. It was like 44,000 watts, something like that. I don't know. I'm just doing math. Quite a bit though. And 6 times 6 was 32. No, 35,000 watts. Something anyway.
Most for 39,000. Yep.
There we go. Yeah, that's right. It was almost 40,000. It was just shy of 40,000. And so, we had that running 24/7. It was fine and good, and it's no problem. Like I said, and on stock PSU, no hardware modification. We're running brains, so there's a firmware mod, but completely stock hardware, 5,000 watts all day long. It's not even a problem. No, I did take it to the furthest extreme, and I forgot who posted this, but there was somebody that posted like a overclocking challenge and an efficiency challenge, and then I took one of the machines up to 8,700 watts, and it starts getting unstable at that point because brains only goes to 6,500 by default with auto tuning. They just haven't gone beyond that because it's such an extreme thing to go anything beyond. Even at 6,500, you're literally talking double the wattage going into it, right? I mean, it's a 100% increase. So it's substantial. And you're just not going to be doing that at home because you give it to somebody, they're just going to go, "Wow, cool! I can go to 12,000 watts." And
that's
you tried it.
You need a team of professionals for that,
and that's it. And I mean, you're talking about all kinds of things like you need thicker cables. Like you can't even have standard cables anymore because the 14 gauge stuff isn't even going to handle that kind of amperage. You're going to literally burn through your stuff, and it's dangerous. It's flat out dangerous is what it is, unless you've really thought through every single aspect of it.
So doubling the overclock there, doubling the power input from 3,000 something to 6,000 something and beyond, you're still keeping the fluid within that tank, that self-contained fluid in there at a reasonable temperature. What is that temperature?
It's between, I think it went up to about 140 degrees Fahrenheit. It's right around there. It's pretty stable.
So that kind of leads to a conversation that we can have here maybe in a few minutes or so. 140 degree heated water, that's got a lot of applications to it.
Mm-hmm.
So that just happens to be a nice sweet spot. I want to backtrack for a second to get you guys' story straight here. You get together, you say, okay, let's develop this HotBox Liu. Let's take the principles of CoinHeated, where we're using the fans and drawing it down and the heat exchanger and all that stuff. And now you're taking the fluid from the heat exchanger, the secondary loop. You're running it through a chiller. How did you say, okay, now that we have this box, it can be used in industrial applications in your racks, and it can be used in the home? For the industrial applications, Anton, what did you have to modify for your containers to make that happen?
Yeah, I would say like containers, we do have full design, and at this moment we still produced only for B2C or B2B. If you want, essentially not going beyond 4 tanks in a set. Obviously, it's modular. You can go beyond 4, incrementally adding them. But in terms of modification, I think one of the things really, it's just you need to think about electrical, whether you have 3-phase power or not. If you have single phase at home, you might be, to the extent limited how much overclock you can achieve. But
Sure, especially if you get a 3-phase dry cooler.
yeah. Yeah, and for 3-phase, yeah, thank you for reminding. For 3-phase dry
You're
cooler,
welcome.
yeah, and yeah, from 3-phase dry cooler, there is a way to go that we definitely plan to convert some of them for home mining to single phase using inverters. So there will be, and this goes back to manufacturing. Actually, when kind of offering this product, it's just thinking like, okay, how to make it still simple. Okay, box is simple. You connect, plug stuff in, remove top fans, and keep bottom as an engine, and essentially keep running it. But how to make sure that it's more like standardized, and we thought it probably will be a good idea to offer 40 kilowatt dry coolers. And dry coolers, obviously, as you guys know, it's good to put anywhere, even in backyard. Of course, you need to think about your noise, and that's kind of separate conversation people often ask about. What kind of a noise level is acceptable, so we agreed on 40 kilowatt dry coolers, 70 and 120. That's kind of where we are right now. And then based on this, you kind of add in boxes, like 3 boxes, 2 boxes, or 1 box. Actually, it goes in reverse. But that's kind of how packages start forming for offering to essentially pleb miners and someone who trying to be between home and industrial.
Would you mind just describing for people that aren't familiar with that process what a dry cooler is?
Yeah, dry cooler essentially it's kind of a big heat exchanger with a fans placed close to it, and there is a different ways how those heat exchangers can be placed. Often there is a table type essentially, or V shape, and through this inside of this heat exchangers you got this small copper tubes through which water glycol flow. And as we know, water is the most efficient heat removal of removing fluid. But we need to add glycol to prevent, obviously, freezing. And the more glycol you add, a little bit less efficient your system became in terms of heat removal. So you need to be mindful, usually, how much glycol you would like to add, whether it's...
All right, so that can be tuned to the specific area that you live in.
Exactly. So, and there's a chart like simply available in Google search. You can look, but you can consult to someone more advanced in this. And I'm sure, John, you'll be covering. You mentioned this conversion of heat, and it will be a separate topic. So I'll stop here.
And that's really the one thing that I find most interesting about immersion is that you can scale the cooling way beyond the air cooling that you would ever get. And I think about like having them down in Texas or in Arizona or Nevada, like out in the deserts, or even any of the Arab countries where they just have extreme heat almost all the time. Running in them on air when you're bringing in 110-degree heat to begin with is already difficult. But once you take the surface area that those that the ASICs have, you put it into the oil, then you can expand that out, pretty much exponentially as much as you want, to put that heat out into the air. So you're not confined by whatever the machine can do. The amount of surface area on the actual machine, those heat sinks on the chips themselves.
Yeah, no, it's a good point. You definitely need to think about the surface areas, and we discuss it. And for hot area, especially if you go aggressive on overclock with hot boxes, we're not yet announcing it or showing it, but we definitely consider for really hot areas if you're gonna go extreme, like 6,500 watts. We didn't mention about terahashes. Obviously, it's changing depending on how efficient you run. On chillers, we was able to reach 165 terahash at 6,500 watts steady, just going from day to day on entire box. Not entire box, but individual miners, full of those S19s. It was, by the way, 110 terahash machines.
And you do lose some efficiency. I mean, the stock efficiency is like 29. I forget it. What is it? Like hashes per watt?
29 joules per terahash.
That's what it is. And it was something per something. And it goes up to about 38, so, and at double the power, you go to like S17-ish efficiency. But the cooler you keep it, the better efficiency you get. So it's kind of a wash. And there's a lot of things that you can do. Like, let's say you have access to a very large water reservoir, you can actually just use that huge reservoir to cool stuff. Or if you have a natural spring and you're just going to route it through there, there's so much you can do potentially once you have the heat in in that liquid, and then you can cool it in many other types of ways.
I think that's a good way to kind of describe to people what you mean by surface area. Like air cooling, you only have so much of that exhaust that is available to cool in the intake. But a heat sink on a secondary loop can be almost anything. It can be a hydronic loop in the ground, just a bunch of coils.
Yep.
Ran 4 feet deep in the ground. What do you have, an average temperature of something like 58 degrees Fahrenheit of the ground?
Yep.
So you run a giant loop 200 feet down and 200 feet back and back into the machine, and there's your heat sink. You can run it down a well. You can run it on a radiator and run water over it, like you said, if you have access to a spring, or run it into a pond.
Yeah, I saw somebody actually do. So they had a heat sensitive switch, and so when the temperature of the water loop reached X, it would bring in tap water, basically, or groundwater. It was from a well, and so that's that 60-degree water, and it would introduce that as needed, keeping a perfectly steady temperature of whatever that they wanted.
If you can keep sorry, I'm just jumping in. I've been lurking.
Who the hell is this?
Yeah, I've been lurking in the background.
What is this? We've been hacked.
Yeah, you've been hacked. I was just wondering, like, the life cycle of these machines, if you can keep this consistent temperature and you overclock them, is there studies done on, like, how long these things are going to last? Are they going to burn out quicker?
So, I mean, if you overclock them, you're definitely going to, it's going to be harder on the machine. There's just no question about that. It's like, are you redlining your engine in your car? If you're just, if you're doing that on every stoplight, is it's going to have a lower, lifespan. But when you keep those temperatures better, if you really keep that consistent, S17s are notorious for being just finicky and high failure rate. But what I found is, even with a minimal overclocking, when the temperature was stable, they just ran and ran and ran, and it was fine. As soon as you start getting temperature swings, you start getting, much different problems going on. And so when I think about immersion and stuff, when keeping those temperatures really steady is a lot better for them as opposed to dramatic cycles of incoming cool. So I think about like out in oil fields and stuff, like when they're doing the flare gas usage and stuff like that. And if you're on air cooled, you have a dramatic temperature difference in 24-hour period that it's going to stress those machines more. And even more so when you have it, if you up in the northern area and you go through seasonally, you can go from 100 degrees Fahrenheit down to negative 30 in 1 year's time, and having that major change all coming into the miner is going to be, it's going to be a stressor.
Yeah, so the consistency is key. I guess it's just like if someone's
Right.
considering overclocking and using immersion, they've kind of got to do this calculation where they take the capex of these machines and everything, and then they work out,
Yep.
well, this is then a depreciating asset, and if I'm overclocking it, and even if it is steady, how much quicker will they burn out? I don't know how you work this, work it out to be the
There's a
most
lot of
profitable.
variables in it. And to be like, why would you do that? Why would you have less efficiency just to get more hash? And then at the same time, like, there's less than 2 years until the next halving. Why wouldn't you get every last bit of hash going right now before the halving and get as much as you can right now? And like, why would you go down and overclock, go down and underclock it, just to have the maximum efficiency? Both are completely legitimate, ways to do it. It's just your personal preference. Do you want the absolute maximum, or do you want the absolute most efficient, or it's up to you.
Yeah, I think one additional point I'd like to bring about this heat and specifically hotbox and dry coolers. For hotter areas, area inside, obviously we deal with air to fluid radiators that actually essentially used fluid to fluid. It's a little bit unconventional way of doing it, and John come up with this. And so there's definitely, since temperature plays a substantial role in efficiency, in hot areas, we even consider right now is two radiators back to back installed inside each tank in a base version. But we might consider adding even a third one, just going through some of those hot areas, hot states, and observing what's happening on the efficiency side of chip. Speaking about Celsius, trying to be just close to 70, 75 on chip temperature. So there's probably opportunities to go higher without any impact if you stay steady. But that's at least target for us.
What's your target temperature for the oil? Is 77, 140 degrees? What's your target chip temperature?
75 C, I think, is what they were reading. It's like 75 to 80 at the most.
Yep, that's kind of what we was trying to stay at, and you have to obviously watch every miner just to make sure that there was a conversation in the morning about removing some of the stickers. You don't have anything that obstructing the flow for your multiple engine that actually like distributes the engine, your fans that move fluid.
Actually, no, I tell you, we were 70 to 75. At 80, we're like, whoa, why is this one too hot? So 70 to 75 was our target for the chip temps.
So when you say you have a wall of machines in a container, air cooled, that you can take a FLIR camera and see that you have certain hot spots on that wall, and kind of identify what machines are running hotter, or where are my gaps in my heat dissipation techniques. If you were run a FLIR camera on your hotbox, can you see that the middle two machines are running hotter, or you keep a good general temp in the whole box?
So I do have one of those, and I did when I was. I haven't looked at them in a long time, but I was looking at them with the aquariums, and I had different setups in the aquariums, and so I was doing those FLIR images, and I was looking at where those hotter spots were, and like which one was which way, and all sorts of things. And you can see it pretty easily just from the chip temps, but with the setup, there's not really much difference at all. Maybe like 1 or 2 C between the machines next to them, and it's almost, it's almost so trivial that it could be any other little thing. But the way that it is, because the heat exchanger is in the center, and it goes from end to end all the way through. So each machine has basically an equal amount, and the way that the water goes through there, there's so much of that equally distributed all along that there's really not much of extra hot spots in there.
Yeah, and I would like to say that if one of those engines fail, and we're talking about fans on the miner, you still can run the box. One of the things when we remove top fans, it becomes essentially your spare fans for replacement if you ever need it. So essentially, you get an additional redundancy just out of the box.
Anton, I know that you hired an engineer, right? Like a thermodynamics type fluid engineer. What has it been like watching the back and forth between he and CoinHeated and CoinHeated's kind of well, I've done the proof of work kind of thing here, and you have studied in a different way. What's that dynamic like, guys?
I'll start off with this, and so the way that I work a little bit more fuzzy logic. In the like, I'm not writing down precise measurements and doing like real time calculations, and I'm not doing stuff in what's the not AutoCAD, but SolidWorks. I kind of have a sense of things, and I have some rough measurements and some rough targets of what to go through and what makes sense in my mind. And Anton had already mentioned this before, but basically, I made my design. We turned it over to the other guys, and he's like, "Well, if we did this other way, and this flows this way instead," and then after a while, he can be like, "Oh no, actually, this original way was the right way."
Yeah, no, it's absolutely interesting to observe those dynamics, and in a way, it's a balancing act. But I truly believe what CoinHeated coming up with, we going back to numbers and trying to figure out why, for instance, something not coming together. But we was forcing to get someone to make sure that we got all the thermal maps, especially speaking about scale up projects on chillers or going to different cooling media. But and at this moment, tendency right now for at least engineers says like, well, if you go to super hot areas, consider one more or maybe even two more radiators inside. And then at some point he even mentioned, maybe you guys at the top, your fans that you're removing, I know it's for splashing, it's kind of in one fence at the bottom, it's enough. But if you keep it for those hot areas, actually you have even more flow inside, just putting miners as is inside back to back, and you'll be able to match those flow to the flow that you get to your dry coolers, and then you'll be able to achieve even more cooling efficiency. So all these kind of interesting concepts, we're not removing them from the table. Obviously, it's first principles. So engineering design versus first principles that are coming up from CoinHeated. But from other standpoint, they agree on some stuff like additional radiators potentially will be added to a little bit wider box that we'll introduce and talk about in the future.
So that's gives you a lot of flexibility when a customer comes to you and say, "Hey, I'm mining in Dubai. Hey, I'm mining in Alaska. I'm mining in Argentina," to where you guys can take these heat sinks and different ways that the machine, the HotBox itself is configured, and tune it to the customer. Have you had to do that yet, or is this still too early phase of production?
Well, and so the tuning comes into the cooling solution itself. So the box itself really is independent, and there's those two parts to it, right? It's what kind of cooling do you have, and then what's your ambient temperature, and really then it's just scaling out whatever cooling solution you have. Because like you said, maybe you just have a stream nearby and you have constant cool water. You can just pick it up from there and send it back out. And if that's allowed and that's available, great. If you're in the middle of a desert and you have nothing but hot air, then you got to scale it differently.
At this moment, we've been staying with the same box, essentially, and just moving a little bit with you guys' feedback. Actually, it's very thankful to early adopters. There's a great feedback coming up on placing, PDUs inside or some other stuff. That's kind of quite interesting. But we try to change as little variables at this moment as possible and work on external side, as CoinHeated mentioned about cooling. There was interesting request to using lakes to cool. It was an interesting request when engineers especially need to jump on board when we kind of go in modular from 3 tanks to 4 to 5 and trying to use same pump, 1 pump instead of 2. Those kind of hydraulics optimization when hard numbers needed. And often really, if you're not going beyond 50 feet, you really stay with the same design that you designed for. You don't need to oversize your pumps essentially for circulating water glycol. That's kind of example we're talking about. One other thing which is important for dry coolers, and it's coming up from engineers very often as a reminder, please place your dry cooler a little bit above the ground. He's very all the time cautious about making sure all this dust not coming in. Then placing whether it's IP54 or 65 on fans, it's important. There is classification, obviously 65 or more. It's great. You can wash it with a stream of water, a heavy stream of water without any issue. Well, IP54, it's a little bit more sensitive. It stay good still on rain, but if it will be like some kind of hurricane stuff, it's kind of less sensitive, more sensitive. So there is stuff definitely to consider. And again, in all this, back to miners, the question is, what do you guys provide? What comes in a package? Do you have, valves, pumps, and dry coolers? So you just got dry cooler. All this, like obviously, we standardizing. We're trying to make it as easy as possible, and really plug and play is a goal, and make immersion mining affordable. That's kind of mission that we put right away. And that evening when we met, is CoinHeated and decided to add to our air-cooled solution immersion.
Do you guys offer kind of like a consultation before you'll place an order to kind of get an understanding of what the situation that the box is going to be placed in, what they're going to use as a heat sink? Do you offer that kind of service?
Absolutely. Thank you for asking this. This is a great question. We offering free designs, and there's no advertising here. Just saying that really we want to help and do 2D, 3D drawings for the miner, making sure that everyone in agreement how everything will be placed, especially if you're not on location. We just learned recently that for some of this like city locations in commercial buildings require obviously some professional engineer stamp of approval. So all our drawings that we'll provide, it's actually good input for let's say licensed engineer to accelerate job and get approval as soon as possible. So it's complimentary, it's free.
It's nice that you guys kind of have that dichotomy of professionalism between CoinHeated, between you guys on the business side and the engineering side, that you can have an engineer design something, and then CoinHeated could come in practically and say, hey, I've actually run into that situation before. I'm the garage mechanic. I'm the inventor. I'm the innovator of this particular product, and kind of get that real world input from him. That's a good team.
It's been a good back and forth between us.
Yeah, he was blessed to have this, and as I said, like he's coming from first principles. I like how you think. My business partner Artyom was super excited. Both of us was this is the way. And yeah, he's learning by doing. Look at his garage. So many variations. He made his mistakes. Why we should go and do it again?
Oh yeah, I've done a lot of mistakes. Trust me.
Yeah, that's real proof of work. So this is Pleb Miner Month, and kind of what we're tuning towards is small scale miners, garage miners, people that are going to start out at home, people that are going to start out in a garage or a small business, and potentially, build up from there, because that seems like the natural progression of things. You always want more machines.
That's where I started.
Yeah, you always want more hash. You just kind of get that addiction.
Yeah, I started with one S9, a 20-gallon fish tank, a cheapo pump, and a $26 radiator from Amazon, and off I went. So it can definitely be done, and it can be fun. I really enjoyed it.
So let's talk about how somebody gets involved with you guys, gets involved in the machines. All right, so let's use me as the example, and this will kind of help me out. Talk to you guys at a conference, both of you. I see one of the prototype boxes. I order a box. I have my machines. I want to put machines in box. What do I do now?
Pray. No, I'm just kidding.
Yeah, no. Basically, if you already order machines, you order the box. You know, you need to make sure that you have your, let's say, dry cooler ordered, contacting us, ordering yourself, and then if you do it ordering yourself, just make sure that you know you can contact us or just go by yourself to sites, you know, properly valves and pumps. There's no like huge magic going on around this, but we'll be able to support you with this essentially connection side, hydraulic and electrical. There is two things really to worry about, and then obviously you need fluid, and for fluid there is multiple options on the market, as you guys know, from you know, premium products to less premium, and we personally testing multiple of them right now, but I'm sure you get own experience, and if not, let's discuss.
What kind of prep do I have to do on the machines in order to get them dunked?
Basically, just take the stickers off is the biggest thing. Obviously, and then the only other thing I'd say is if they're used and they're air cooled, take it apart a little bit and blow it out and get all the dust out.
Yeah, you have to decide also whether you want to, how far you want to go with overclock. That's kind of a good question to ask, because it will determine your PDU, it will determine essentially your PSU, whether you need to upgrade or not. And PSU ranges, by the way, in prices from 300 to, like, say, 500, depending how fancy you want to go.
There used to be a lot of discussions, you know, when kind of Bixbit came out and DCX came out with their tanks, as to whether to remove the heat sinks and remove the thermal paste. What is you guys' opinion on that?
You know, I've left it on the thermal paste and stuff, and it's not going to chemically change the fluid in there at all. It's already not conductive, so that part doesn't matter. There's not enough of it. The only thing I would say is if you're going to take it back out of immersion and go back to air cooled, and why anybody would do that, I don't know. But at that point, you would need to reevaluate the heat sinks and the paste and everything else before going back to air cooled. But other than that, I just take the stickers off, because it will dissolve the adhesive of the stickers, and the stickers will come free and clog things up.
And you always have more stickers than you thought.
Including the fans.
There's a lot more on it than you think. There's ones on the fans, there's one on the side, there's ones here. It's like, man, how are there any stickers around here?
Yeah.
So go ahead, Anton.
No, I said, like, usually once you find it at some of the temperatures start changing, especially in the early stage. You're like, okay, it looks like one more sticker I think I forgot about.
So you have tank, you have PDU, you have cables, you have fluid. You put your machines in the box. Well, first you prep it. You take the intake fans off. Do you need spoofers on those fans or on those machines?
No, you don't need spoofers. And that's kind of one of the beauties of plug and play and CoinHeated approach, just removing and overriding some of this complaint from brains that we typically use to run it, and it works perfect.
So now with the standoffs, and
I should note real quick on
the three of us have kind of. I'm sorry. Go ahead.
Oh yeah, I just want to say one thing on the fans real quick. If you're using stock firmware, then you would need to do very different things. But it's the reason that spoofers are not required is because of aftermarket firmware such as Brains. I think Vanish would do the same, although I have not specifically used that. You cannot use stock firmware and run fans in immersion. It's just not going to work.
I want to kind of get into the control board thing here in a second. So the three of us have kind of been back and forth a lot throughout the past months about standoffs. Now those machines need to be up off the bottom of the tank a little bit. What's the solution that you guys have come up with, and can you kind of talk about the journey of your thought process?
Sure. So I do some really basic 3D modeling, and I have a 3D printer, and so I was just going through like general ideas of how do I get this oil to flow, sucking it down through and getting it to go over to the side and then back up through. And the wonderful thing about 3D printing is you can just, it's not super fast, but it's a lot faster than making a mold and going through an actual design process. I can make something, print it out, and the next day I've got something to test with. So I went through a lot of different designs and a lot of ideas that were complete rubbish, and I ended up on one that was really a lot more complicated than it needed to be. And even at the fastest speed, it still took like 18 hours to print one thing, and it took an entire kilogram of material. And it's just like when we're looking at it, like, yeah, it works, but how do we do this? And we can look into doing a pour mold. In the end, I actually went back to a much simpler thing of just doing a folded aluminum standoff, which is what we're going to go with long term. Because really, the only thing that you need is to have it up off the bottom by about 50 millimeters, and then have that downward oil forced into the center of the tank, which then forces it through the fins of the heat exchanger, and then back up and cooled along that path, and then back in again.
So the fluid has nowhere else to go.
Exactly. It just cannot go anywhere.
Yeah, and standoffs coming up with a box, just and latest design on this aluminum design, it's actually super simple. It's again, the purpose is to lift miner, create individual channels of flow, even miner, top miner at the level of essentially your radiator. And radiators right now, there is special size that currently designed for the box. It's actually John's. Experimental. He tried different stuff, and I think that was last one that we not going to change for a while. And it will be part of the package, and it's very, very simple to install.
Charging the secondary loop. So say a customer chooses the dry cooler option. You're going to need a certain amount of water. You're going to need a pump. Do you need an expansion tank for that secondary loop? And describe to customers what they would need to do, like what they would need to describe to their plumber or their HVAC guy or to themselves in order to get that secondary loop charged up with a water glycol mix.
Yeah, essentially, you will need a tank to mix water glycol. We'll provide you essentially a volume that you will need. There is a absolutely needed expansion tank. The standard, I'll reconfirm you. I think it's like 14 liters. I'll double check. Five gallons. Expansion tank, and at close to expansion tank, we'll have a connection to the pump that will be used. You can connect pump and charge the system. There will be procedure provided, and we'll do a lot of videos. And John also on the way to do probably a couple of good videos that will be in simple terms explaining how to plug and play and start running as quick as possible.
Can you offer people support if they choose a different heat sink? So just to kind of reiterate on the,
what do you mean?
Well, a way to dissipate heat from that secondary loop.
Oh, like instead of a dry cooler, you mean?
Yeah, not everybody has to choose the dry cooler option.
Yeah, when you say heat sink, I was thinking of the actual on board.
Oh, the radiator. The heat exchanger.
The miner itself. I'm like, wait, what?
Oh, no, not in that sense. In a thermodynamics sense.
We'll be offering support and already offering support. Absolutely. Just let us know dimensions and as much details as possible about your essentially heat exchanger, your fan, and we'll be able to, and make sure location, like draw it by hand, just send it to us. We'll be able to design for you and tell it, at least from engineering standpoint, is it sufficient or not, or you need to upgrade yourself on fans or just add a little bit more, just increase size of this heat exchanger. And it on specs, it will be like tubes, dimensions, and density. There's multiple things that you don't necessarily need to understand, but just try to get from your manufacturer supplier as much information as possible. And if you have detailed drawings, and we're talking about installation of 2-3 tanks, like a little bit big installation, not just one tank, we can do all this 3D model, design, and just I mentioned it will be complementary as soon as you get box. And we understand all this. It's not occasionally it's not straightforward at the beginning, but in reality, it's just plumbing work. There's a lot of plumbers around. They just need some guidelines, and guidelines will be provided.
I just want to say, for my personal experience in knowing you guys over the past 6 months or so, that you guys are stand-up guys. And anytime that I've reached out to you guys, even for the stupidest of of issues, or attempting to make my own standoffs, or kind of the issues that we've dealt with and run across, that you both have been men of integrity, and just a personal attestation. I'm impressed with both of you. Not
I
to get too
appreciate
mushy.
that. Thanks.
Yeah.
Well, I mean, I think it goes back, really, I'm a pleb at heart, and I'm appreciative of everything that everybody else has done before me. And just because I came up with this completely different way, I wouldn't have gotten to where I've gotten to if all those other people before me hadn't done all the things that they've done. Like, can you even put an ASIC in a tub of oil and use different firmware and all this stuff? It wouldn't have never have even happened if it wasn't for all those people and answering questions on stuff. So I just like giving back, and I'm not in it for the money. I'm in it for the Bitcoin. If that makes sense.
It totally.
Just Bitcoin's money and whatever. But yeah, it's just I'm doing it because I actually enjoy it.
Yeah, John, you didn't mention about all your achievement through this communication. You've done a lot of cool stuff, from standoff printing to beautiful painting, beautiful box, and doing all this innovation of how you place and stuff. You should brag about this. That's kind of very, very impressive.
Well, just the pictures on Twitter will be enough. We didn't get a chance to talk about kind of, I think, one of my favorite things and one of CoinHeated's favorite things. So we'll have to have you guys back on the show to talk about what we can do with that secondary loop, and not just take it out to a dry cooler and waste that. I know that's something that we're all very passionate about.
Yep, absolutely.
So I think that kind of deserves its own podcast.
I would agree with that completely, because there's so many options.
Yeah. I think you and I kind of sat you and Sarah and I, after the after party of that conference, just nerding out on all the possibilities what we can do with waste heat. That's the conversation in itself.
Yep.
Guys, I really appreciate you stopping by for Pleb Miner Month. I appreciate your contributions to the community and helping out. Where can people kind of see the HotBox, and how can they order one, and how can they interact with you guys?
Yeah, at this moment, we are located out of Houston, Texas. Email actually provided in a Telegram, Telegram, not Twitter, and website info@AIProEnergy.com. We, as I said, like working as a team with CoinHeated, and both of us, and we got engineers also ready to support. We say 24/7. We try to be 24/7. Your installation. Yeah, I think that's kind of easiest way. Just DM in Twitter, or just send a mail. Just call. There is a phone number as well.
Yeah, and my DMs are always open on Twitter too, @CoinHeated.
Guys, on behalf of Max and Mr. Crown and all the ungovernable misfits that are involved in Pleb Miner Month, we really appreciate talking to you and hearing from you, and hope to talk to you again in the future.
Likewise. Thanks for having me.
Yeah, thank you for the invitation.
Thanks for listening. Make sure to check these guys out. I've put all of the links in the show notes. In fact, that's actually a lie. I haven't. John did all the show notes because I'm too much of a retard to do proper show notes. So thank you to John. He's actually been doing quite a lot of that, really helping me out, and I really appreciate it. Also, a massive thank you to Mr. Crown. Mr. Crown is the man behind a lot of the design on the website, a lot of the clothing, and he really pulls everything together. He lurks in the background. He's not someone who really likes a huge amount of attention on him, but he's a fucking genius with this sort of stuff, and I absolutely love working with him. Even if you do nothing else today, make sure you go and do this. Follow @Mr. Crown. It's a fucking disgusting spelling, but I'm going to read it out anyway. It's @MrCrowNNNNN. Go and do it now.